Hello, ladies and gentlemen. I hope you're all doing well and you're ready for question number 7 on our 2011 Euclid paper. So it's the last light bulb of the contest. The rest of the paper is written from here on out, and so is B part as well. But what do we got for A? A 75-year-old person has a 50% chance of living at least another 10 years. A 75-year-old person has a 20% chance of living at least another 15 years. Interesting. An 80-year-old person has a 25% chance of living at least another 10 years. So it looks like we're being given a bunch of probabilities. And there we go. What is the probability that an 80-year-old person lives at least another 5 years? Okay. So we want to find this probability. Let's give it a name P. Now, when we deal with probabilities, you don't actually work with percentages. You work with numbers between 0 and 1. So we might say, the probability that an 80-year-old lives at least another 5, we'll call that P. And then we're told some other probabilities. 80-year-old lives, 10, right? Lives at least 10 is 0.25. Probability a 75-year-old lives at least 10 was 0.5, and then it was 0.2 for 20%. 20% out of 100% should just simplify to 0.2. So 75 lives at least another 15 is 0.2. Okay, so we need to use this information to figure out P, because this is a math exam. This is not an actuarial test where we would have to look up actuarial tables or anything like that, and mortality rates. Okay, so how do we approach something like this? Well, a 75-year-old living at least 15 years looks a lot like an 80-year-old living at least 10 years. Both of them are making it to at least 90, right? So how does a 75-year-old lives till at least 15 years, lives at least 15 years more? Well, they first have to live to be 80, and then they have to be an 80-year-old who lives at least 10 years more. So we break it down. So to be 75 and live until you're 90, you first have to live till you're 80 and be an 80-year-old who lives at least 10 more years. So we'll say you have to live till you're 80 and then live another. All right, I'll add in the word then. And then as an 80-year-old, live another 10 years. Okay? Now, when we deal with ands or and thens in probability, this is multiplication, something I teach my introductory or first year finite math class. I teach these guys this a lot. So you have to live to your 80. There's some probability of that. I'm going to call it Q. Times the probability that you're 80 and you live, I don't know why the I's are not showing up, live another 10, which I know. And I know this as well. So 0.2 is Q, the probability that a 75-year-old lives till they're 80. Actually, we should probably write that 75 living to 80, times the probability that an 80-year-old lives another 10 years. So this is Q times 0.25, and now I can rearrange and solve for Q. And you're saying, how does that help? That's not the original probability that you're asked for. Give me a moment. 0.2 over 0.25, so that should be 4 out of 5 or 80. So 0.8. So there's an 80% chance if you're 75, you'll live to your 80. Okay, now what do we want? We want the probability that an 85-year-old lives another 5 years. Okay, so that means they would go till they're 85, at least. Do we have something else where somebody lives till they're at least 85? Absolutely we do. The 75-year-old living another 10 years. So how does a 75-year-old live for at least 10 years? Well, first, they're 75 and they live till they're 80. There's a certain probability that that happens. And then they are an 80-year-old who lives for another 5 years, at least. And And we want this probability. This is what we call P. We know this probability is Q, and we see that beloved and then, which means you multiply. So we know this probability is 0.5, that they just live another 10 years. That's Q, which we know is 0.8, times P. So the probability we want is 0.5 divided by 0.8, or 5/8. So the 5/8 chance, did they ask for probability or percentage? Probability, so we stick with 5/8. If you were curious, I think it's 65.2% chance. But I think probably both of them would be acceptable answers, but they did ask for probability, so technically you want to write 5/8 or 0.625. Okay, so there's our final light bulb question. What have we got for our written question? Oh, it's a log equation question. They throw these at you around questions 6 and 7. Determine all values x for which 2 to the log base 10 of x squared is equal to 3 times 2 to the 1 plus log base 10 of x plus 16. So I'm seeing the 16, that's 2 to the 4. Something, and maybe get everything as 2 to the something. That seems possible. I don't like this 3 out here, though. That makes me a little unhappy. Now, what can we do? Let's copy the expression. I don't like the multiplication out here with something that's not times 2. I don't like the addition as well. So there might be another way to approach this rather than get everything with base 2, but I am glad I spotted the base 2 in case that's what we need to do. I want to bring this, this 2 from the x squared out front, and that's a logarithm rule. If you got an exponent inside a logarithm, it can come outside as a multiplication out front. And that means we won't have an x squared in here. We'll just have log x. I'm going to split up the 2 to the 1 and the 2 to the log 10. Because now what can we do? Well, there's a rule that says if you got a to the power of a product, you can rewrite that as a power of a power. So I'm going to bring this 2 here outside everything. Okay? And you don't actually have to be drawing what you're doing. You just, write a series of expressions. As long as you're not doing too much at once, everyone will be able to see what you're doing. I'm going to combine the 2 and the 3 to make a 6. Okay? And now at this point, I'm going to actually say something. I'm going to say let y be 2 to the log base 10 of x. And you'll see why in a moment, because this whole thing turns into y squared. Now we've got 6 times y plus 16. And now I just have a quadratic. So I could solve that in terms of y. So minus 6y minus 16 equals 0. Can we factor that? Minus 8 plus 2 should work. Okay. So y is either 8 or y is negative 2. Great, that's fine. We weren't asked for values for y, we were asked for values for x. So we need 2 to the log base 10 of x is 8, which I'm going to write as 2 to the 3, or 2 log base 10 of x is negative 2. But unfortunately, 2 to the anything will never be negative. Now you could write that off to the side, or you could just do what I do, which is put an x through it and say, not valid or does not work. Okay? But now this expression, well, now we can say log base 10 of x has to be 3. And from there, you rewrite the equation. 10 to the 3 is x. That's exactly what log expressions do. They just rewrite exponential expressions. And so the only answer is going to be x is 1,000. Now, knowing that, what you could do is if you got your calculator handy, you could grab it, as long as it's got a logarithm button on it. You could then start plugging it in. So log of 1,000,000, which would be 2 to the 6, is 3 times 2 to the 1 plus log of 1,000. So 3 plus 16. 64 is 3 times 16 plus 16. And yeah, it is. 48 plus 16 is 64. So that all worked out. You do have to be careful when you see functions or logarithms or square roots that you don't just blindly say, well, this answer must lead to an answer. It's entirely possible, and it happens a lot with logarithms, that you just can't reverse engineer. 2 to the something is always positive. Okay? Sadly, doesn't ever become negative, so we don't get an answer here, and you gotta watch out for that. Okay, but there we go. That wraps up question number 7 quite nicely. Up next, question number 8, and we begin the big 3 at the end. I'll see you for question 8 next time.